Okay, so you've done some work in class about working out gradients, and we're going to look at how we work out a general rule for working out the gradient of differentiating a function. What we've got here is a polynomial. So you remember that what you've done, the definition of the gradient is the change in y divided by the change in x, which equates to y2 minus y1 divided by x2 minus x1, where y2 and x1 are coordinates of points we're interested in. So on this graph, we've got no numbers, so we can't work any gradients out from it. So we're going to have to use a little bit of algebra to solve this. So I want to work out the gradient at this point here where I put the black dot. So first of all, we need to find the coordinates of that point. So this point here is quite straightforward. That is just going to be the value x. And my function up here tells me to find the value of y. I just have to square the value of x. So this is going to be along here. So it's going to go. So x, so this has to be x squared. We're okay with that. So the function says to find the value of y. I just need to square the value of x, and that's what the function. So now I can create my first coordinate at this point here, which is going to be x, and the y value is going to be x squared. And now I can identify this is my x1 and my y1, like you've done before when you've been physically using the graph paper to work these gradients out. So if I put down, use my ruler to show what the gradient should be. So the gradient should be, if we just put it down to that black point, something like that. I'm going to times it here. So that's what I want to find the gradient of that straight line, and we know how to do that using changing y divided by the change in x. So because I don't know any of these values here, but I do know the relationship on the curve, I'm going to put another point up here as an estimate. So I'm going to pick a point here. I'm going to put this green point in here. So I can work, I know this is on the curve, this is on the curve, so it's going to make life a little bit easier for me to do. So let me see what that gradient looks like if I just connect the black dot and the green dot together, because this is going to be the estimate of the curve on gradient I've got. So it is out, but it's an estimate, and we're going to see later on how we improve that estimate. So let me work out the coordinates of this green dot. So let's come down here. This is going to be one to know the coordinates of that point there. If you look at what we've done, we've taken this value of x and we've moved it by a certain distance to here. And if I call that certain distance h, then you can see that this point here is going to be x plus h. That's what we created. So now I need to work out what this point is in the y direction. So again, if we go along to here, remember my rule up here, y equals x squared, so whatever value the value of x is, I need to square it. So in this case, I've got x plus h. If I square that, it becomes x plus h all squared. So now we're in a position to put the coordinates of my green dot. and then I can work out the change in y divided by the change in x using the formula we've got over there. So if we write this out, my x value for the green point is going to be x plus h, and the y value is going to be x plus h all squared. So now I can identify my second set coordinates as x1, x2, sorry, and y2. Now I've got all the information I need to use my formula. My formula up here says gradient is y2 minus y1 divided by x2 minus x1. And I've got all that information on the graph now. So let's do that. So my gradient is going to equal y2, and y2 is x plus h all squared, and I need to take away my value y1, and y1 is going to be x squared. And I need to divide that by x2, take away x1, so x2 is going to be x plus h. I'm going to take away x1, which is x. So we just need to simplify this a bit. So we need to expand x plus h all squared. So however you want to do that, we'll just do that here. So we've got x plus h, x plus h. So multiply everything by x. I'm going to get an x squared. Multiply everything by x again, and we're going to get x h. Multiply everything by h, we're going to get a x h again, and then multiply everything by h, we're going to get a h squared. This simplifies down to x squared plus 2 lots of x h's plus h squared. So what we'll do, we can add that in now and just do a bit of algebra. So this is going to be x squared plus 2x h plus h squared minus x squared, all divided by x plus h minus x. And what we'll do, we'll see what we can cancel out. But you can see on the bottom we've got a plus h here, and we're going to take x away, so that is going to cancel out. And if we look at the top one, well, we've got an x squared and we've got a minus x squared, so they're going to cancel out as well, so they'll be gone. And then we can just simplify this a little bit and see what tells us. So the gradient is going to be 2x h plus h squared, all divided by h. So we can simplify that a little bit, make it a little bit clearer. So that is the same as no, I'll leave that there, and I'll just simplify it below. So that's the same as 2x divided by h over h plus h squared over h. So we're nearly there now. Again, we just look at see what we can simplify. Well, this first bit, 2x h divided by 8, the h's will cancel out, so that h will disappear with that one. And if we look at the second one, we've got h squared on the top, h on the bottom. So if you look at your laws of indices, that will just come down to h. So if we write the gradient that we've got, so the gradient, if I just put it over here a little bit. So therefore m equals 2x plus h. So whatever value x is, I'm going to multiply it by 2, but I need to think about adding that h on. Now we're going to come back and look at this graph here. So the green line is an estimate. We've got to think about how we can improve that estimate. How can I get that green slope close to the y slope? What is it I need to do? Well, the easiest thing to do that is to take my value of h and make it smaller. So if I had made it, if I made it here, if I brought my green dot here, and then I connected my line to it, you can see that actually that gradient is getting closer to it. So I hope you can see now that if I make h really, really small, keep on getting that close to my x value, then that green gradient is going to get very close to what I want. So if I had put my green dot right here and try to draw my line of the gradient for these 2 points added together, you can see it's virtually going to be on that line. So what I can do, go back and look at my formula now. What we've seen is that if h approaches 0, gets very, very close to that black dot, so small that you can't even measure it, then the gradient is going to equal 2x. So for any x squared curve, any quadratic, so if you've got a graph y equals x squared and you've got the values on it, to find a gradient at any point, you just need to double the x value to work out the gradient. So that's our rule for that. And what we're going to do now, we're going to finish that there. If you want to go over that again and see what we've done, see if you can follow that, because this is quite key to what we're doing, understanding when we give you the rules for differentiation, where they come from. So we'll leave that one, and then the next video we will look at doing